Good afternoon, ladies and gentlemen. Welcome one and all for Bharatri's Speak series of webinars. Bharatri has been continuously engaged in bringing clarity and knowledge, especially on the topic of risk. We've been talking to various experts and specialists to unlock the realities of how risk operates for a business. And in this series, we have been meeting people from the cyber security industry and other industries. Today, we'll be talking to Mr. R.R. Balakrishnan, insurance and risk management sector veteran. We'll be discussing with him so many points which could be very useful for industries in general and in particular to the process industry. What I mean by process industry would be chemicals, petrochemicals, bulk drugs, what they call API, and other type of industries which have a continuous process. There is a chemical reaction involved. So what kind of issues that could be there for them as a matter of risk, we'll be discussing with Mr. R.R. Balakrishnan. Welcome, Mr. Balakrishnan, sir. Good evening.
Good evening. Good evening.
Yes, sir. Go ahead, sir.
Yeah, Arun, you go ahead.
So, to give a background to our participants, Mr. Balakrishnan is a chemical engineer, and he has seen all sides of how industry operates, particularly the process industry. He has himself worked in process industries. He has set up a project and operated an industry. And then from the insurance side, he has been a risk engineer. He has been an underwriter. He has been a claims assessor. He has been a surveyor. And for the past more than 2 decades, he had been very busy, engaged in safety, risk management, and insurance topics for various customers, not only in India, but outside India. He has built a rich experience in these areas, which is found to be very useful to business owners, particularly where there is a priority to bring focus on risk issues. It could be possible that in a passionate involvement in running an industry and taking care of so many priorities for being busy in the enterprise, there could be some issues about risk which might have been overlooked. So all it takes is for a business owner to talk to Mr. Balakrishnan to achieve clarity as to what could be missing when it comes to prioritizing risk. And I'm sure hundreds of Indian corporates have benefited from the knowledge of Mr. R.R. Balakrishnan. He is the principal consultant of Asia Pacific Risk Management Services Limited. He's headquartered in Chennai, but they have clients across the country in India, and they also have clients outside India. And these clients are represented in every other sector or domain. But there's been a concentration of process industry, which is why today we'll be discussing with Mr. R.R. Balakrishnan what could be risk-related issues and priorities for process industry. So on your behalf, I would welcome Mr. R.R. Balakrishnan. It's a very interesting session today. We have registrations from not only India, but countries like Sri Lanka, Kenya, Tanzania, and Uganda, and a few other countries. So I welcome our guests from all those places outside India. We appreciate your time for attending this session. I'm sure this discussion will be very useful to you as Mr. Balakrishnan will help us to discuss more. Sir, Mr. Balakrishnan, I mentioned about your journey in the risk industry, the safety industry, and the insurance industry. Shortly, please tell us about your 4.5 decade journey, sir.
Thank you, Arun. Actually, I started my career in the design projects in Calico Chemicals, but quickly moved over to a process which is being developed for manufacturing of paracetamol. And I had gone through some of the horror stories there because even one fire has taken place. Now, looking back at that, I realize how ignorant I was. But looking ahead also, I realized there are many areas I am still ignorant. But then I decided the most exciting field should be risk and insurance. So when the general insurance went ahead and picked up engineers for risk management, I applied and I got it. And the starting point of engineers entering into most of the insurance companies is Flixborough disaster. In the Flixborough disaster, the insurers burned their fingers because they always underwrite with reference to probable maximum loss, what can go wrong and how much it can go wrong. And completely their computation and calculations were wrong. And they realized that this is not a job just of an underwriter, but a risk engineer who can conceive this and really bring to the table what could be the worst case scenario. So that is the starting point, and that is where I started my career. And I was involved in formulating the petrochemical tariff for GIC. Then I moved over to Tata's, and then later I went into loss adjusting, that is survey profession. This is one profession where you really see day in and day out your major disasters. So when you go and ask for details, your focus, fortunately for me as a chemical engineer, my focus was not just assessing the loss. I was also looking for the behavior of the structures when something goes wrong, and also what are the contributory factors which really trigger such a loss, and what are the problems the every unit faced when they were trying to really mitigate such a loss, including coming back quickly into the business as a business continuity. So as I was going on this line, after some time, I realized that risk management, that is safety and safety related, is very exciting because it is preventing. It is not like ambulance chasing. After a loss, you go back and try to do this. Somewhere I have to exchange whatever little I know with the community, and so I got into it. And that led me to creating because my friend Mr. R. Tyagarajan of Sriram, he was keen on creating that kind of expertise inside India so that it can be of significant use. So with his help, we created Asia Pacific Risk Management, which is doing its bit, whatever a little they can do in this area. But one thing in the beginning, I would like to make it clear. Even today, I feel vulnerable with respect to the knowledge base, with reference to all this risk and safety related things. Because even today, I have been asked to do many root cause analysis, and then I find most of them, I wonder, I would have pinpointed out or I missed out. So this is there. So the vulnerability is very much there, but at the same time, there are a lot of learnings are there, which also have prevented many accidents when we did audits and interacted with the community. So that's the journey, and the journey continued still. Ultimately, the life exit from this body.
Very nice, sir. I'm sure your learning and your experience will be useful to business owners wherever you meet them. That's ultimately the utility and value of what you have learned as a professional. You mentioned about root cause analysis. So let me start today's discussion on something related to that. We have seen as many incidents that have taken place in the past years, particularly the last year. Even when the shutdown happened due to pandemic, there were industrial accidents, there were incidents of fire or explosion. In your experience, what has surprised you in terms of cause of loss?
No, whenever you, instead of going specific into your question, I will also say whenever I visit industry which has suffered a major loss, first the gloom sets in actually, because an incident is not just a loss of money or loss of business interruption. It is a loss of life, and it has got a cascading effect. For example, I still remember in one of the major petrochemical unit, after damage, it's a first vapor cloud explosion I investigated in my life way back in 1991. And when I went 1990, when I went there and I was discussing, I was staying in the guest house and I was discussing the scenario that was told by the people were very depressing. The thing is, Nearby the plant, there is a housing colony where all the family members were staying, and they came to know a major explosion because they heard the major explosion. And many of the people were wondering, the wives were wondering whether the husbands will come back, the children were wondering whether the fathers will come back. And many of the people, the nearly 30 people died. Naturally, some of them lost their loved ones, and some of the children lost their father. Why I am saying this, when you are looking at risk, you are looking at lives, your life and the interrelated lives, and also you are looking at the real to assess a risk. You have to have this feel in you that it has got such implications, so you just cannot walk across that without recognizing it. It is very critical. But you asked me what surprises me. The most, the surprise, if you really ask me, is a repetitive nature of some of the cause of losses that really triggered major loss. For example, I was talking about Flixborough disaster way back in 1974 or something. I don't really remember exact year, in 70s, 1974, I think, where a bypass was created because one of the reactors had a crack, and so they made a bypass without undertaking proper stress analysis and other things. So ultimately, the pipeline gave away, and cyclohexane came out and created a vapor cloud, which triggered a major disaster, and 28 people died. But the similar incident took place in India in 1991, where also another bypass was created in a place where there was a clogging of plate exchangers in the incoming gases. So in order to see which of the plate heat exchanger is getting clogged, they made a temporary bypass with killed carbon steel, and that gave away, and that created a vapor cloud, and then vapor cloud explosion killed 30 people. So the first surprising element is the repetitive nature, in spite of knowing across the industry that certain things really trigger major losses, and saying, still if you really discuss with people, it is not really soaking into them. And when the incident takes place, invariably I come across some of the top people in the organization said, we never even thought such a thing can happen. And you generally wonder why such a remark is made. The other side of a surprise is a pleasant surprise. This surprise is, I go to a plant and it has got a major explosion, which is ripping apart the vessels practically into a sheet. But when I go and ask them about the casualty, and they say no, they were smart enough to evacuate the place very rapidly, and there is hardly any casualty. There is no casualty at all. So that is a very pleasant surprise you get. For example, I'll just show you one slide, which is the first my learner on this. Can I share the screen?
Sure, sir.
Can you see that?
Yeah, in a few seconds. Yeah, it has come.
Yeah, what you are seeing here is a vessel, reaction vessel, which has been ripped apart. And remember, this is a reaction vessel, which is a vented vessel. In other words, if there is a pressure buildup, it will get relieved through the nozzle. It's a vented vessel. But what happened, there is a nitro compound which is being hydrolyzed. The rate at which the decomposition that took place for unknown reason, because this process was going on in Germany for 30 odd years, and it was taken up in India. It was also going on for 5-10 years. This is way back in 1980s, 80s. This is. The whole vessel was really pressurized, and it was ultimately ripped. And when it ripped through, you can see that the whole of the wall, which is an 18-inch thick wall, literally 2 bricks, they are knocked off. So a brick wall against an explosion is, you just cannot really take it for granted that it will prevent you. But at the same time, see this control room, which is a blast-proof control room full of RCC, it was able to withstand the overpressure, and it was on the side they had the brick wall. After that, there is a blast wall is also there. They were all knocked off. The reason why, so there are 2 or 3 lessons I have learned in this process. Number one, as soon as I went, I asked, as usual, how many, is there a casualty? And they said, no, there is no casualty. The operator was very smart. He escaped the whole thing. So I wanted to meet the operator, because you need to learn how he handled the situation. Then he said, sir, it is just a day before Deepavali, and very thin manpower was there. And when the pressure was building, I could see the vessel getting stressed, because there is enough vibration was there in the vessel. So I decided I will run away from the scene. See, there are situations I have come across in many of the incidents where the situation is getting out of hand. People rush to the place and try to resolve that issue there. You can't resolve certain issues standing there and looking at it. Even if you have to resolve, I would prefer not to resolve when the pressures are building up. It is better to sort of getting out of the situation. But I know 13 people dying in Hyderabad during runaway reaction, people trying to, and this was, and similarly in Ankleshwar, people were rushing into a vapor cloud which had a flash fire, and really 7 people died. So the point is, how do you handle the emergency is another thing. If you want to, that is the first learning I learned. And the second learning was, of course, this thing that the wall, which is made out of brick, is no barrier at all. I have found out even in some of the petrochemical units, the sprinkler valve is being barricaded by brick wall. Actually, the brick wall can create missiles. So that is the thing. So along with these surprises, I was able to have these lessons which were useful in subsequently when I was interacting with people, which I will cover later.
Fine, sir. I mean, it's been a fascinating story to realize all this as you visit one incident site after another. You correctly mentioned about the gas leak incident which happened last year during the pandemic. Especially incidents like those, if somebody is asking if I'm an entrepreneur, I have a chemical unit where I handle gas. If I ask you, what should I do to mitigate? Can you quickly say 1 or 2 points? I know your advice has to be more detailed, but what would you advise to a business owner when it comes to mitigation of such incidents?
See, this is a very complex problem, to be very honest with you, because when I put up a plant, there is hardly any human habitation near the plant. If you as the days goes by, I am sure even in the case which you are referred to, where the release of material took place, I think it is a way back 1950s plant, and then it became handed over from people to people, became then it is a polystyrene manufacturing unit. But the point is, when you start allowing people to come to your boundary wall, you have no choice. I mean, you are. I mean, the whole community there becomes extremely vulnerable. See, there is a lot of negative this thing about the chemical industry, but all of us use everything that is chemical industry is producing. Tomorrow, if today, without the group of medicines, basic drugs, our longevity would not have really increased. And similarly, from perfume to fertilizer, where food has to be this thing, or agrochemical or fuel, name it, all of them are through this, chemical process. Satisfactory, but at the same time, the process involved is hazardous. But the question is, when a hazardous industry is situated, if nearby, if the people are going to come and reside, naturally there is going to be a potential thing. But the question is, how do we deal with the situation? You can't be complaining about it, because that is what it is. And the best part of it, you have got to really do risk analysis, quantitative risk analysis, and similar such tools have to be used to find out which are your vulnerable points. See, the most important thing in a chemical industry is you must feel vulnerable, and you should monitor continuously that things can go wrong, where it can go wrong, and what are the telltale signs that just like our health system. Our health will tell you 101 times you are not all right. Please go to a doctor and have it examined. But we still believe that nothing will happen to us. That aspect, nothing will happen to us, should get away from us. And we should always, at the same time, we can't be thinking all the time, yes, I can't produce because something is going to happen to me. So the point I'm trying to communicate is, all the time, you have got to identify the scenarios which are going to really hit you badly, and what are the root causes that can trigger the scenarios, and then train everybody and make them feel and understand and create a risk perception in them. And the whole organization should have that basic culture. And so anybody and everybody looks at deviation, reacts to it. And once you have that thing in you, you are like a hazard warning system. When you go into the plant, everything will be talking to you immediately that I am not all right here, I am not all right here. Then you attend to it, don't postpone it. And that is the reason that that is the thing they have to do it. So one is understanding your risk, appreciating the risk, then making it other to perceive the risk, and create systems and other things which you continuously practice it. So whatever you know, it's an instinct to you in operating the plant. So you instinctively operate the plant safely. That's the point is very critical. And the top management involved is essential. What the top man thinks, everybody else thinks. What is important to him is important to others. So that is very important, critical.
I agree, sir. So safety and risk management has to be top-down approach. The management appreciates and realizes what's important for the organization in terms of safety and risk management. But from your viewpoint, sir, in the past few decades, how has been the shift in terms of priority and philosophy towards risk management? Has there been an improvement, or is there a deterioration? What's your thought process about how management accord priority to the issue of risk management?
No, there is definitely a significant improvement. I wouldn't call it not, because not only the plant personnel and the owners are keen on seeing, for two reasons. One is they are also keen to have a business continued from across the world. They want to know that there will be a business continuity, no incident will take place. So secondly is they know that if something goes wrong, and that is the end of the story for a plant. So they know their vulnerability, they are fully aware. Then the statutory authorities. The statutory authorities are also now keen that certain type of studies needs to be done, and certain types of trainings and other things have to be in place. So it is coming from the statutory authorities also. So as a society and as a chemical process industry or this thing, it is definitely improved. But what I believe is that culture has to move over to other process industries. For example, if you really see the major disaster that took place in Imperial Sugars in US, I mean, nobody was thinking that kind of a dust explosion could really occur. But again, it is due to some plant modification that has been done, and the dust were captured in the conveyors, and ultimately it triggered explosion, which propagated secondary explosions. So what I am trying to say, this risk, what we learn from nuclear industry, what we learn from aerospace industry, it moves over to chemical and petrochemical industry. Then it has to move over to other process industries like bulk drug and other things. Then it moves over to even engineering industry, paper industry, and others. Today, engineering industry uses a number of chemical processes for improving the metal structures and things like that. So it is a holistic cross fertilization of ideas, and this thing is very essential.
Fine, sir. I mean, I note that you are quite positive about how this attitude toward risk has been there over the past few years. Sir, I want to ask you about one particular aspect. It's very important, but not frequently discussed. I have heard you in business discussions, you always mention about near miss incidents. How it is important for plant management or operational management of a plant, chemical plant, to capture and report. There should be a reporting and analyzing of near miss incidents. Can you tell us about why capturing near miss incidents is very important for the safety and risk management?
Yeah, definitely. As I was telling already, a part of that I think addressed the near miss or the hazard warning system. And very many times the near miss is considered as a thing that happened but not culminated in an accident. So if you say there is an incident, suppose let us say something falls from the pipe rack or somewhere else, some solids, and if somebody would have gone under that without a helmet, and he would have, it would have hurt and you may die. So if nothing happens, he says there's a near miss. But my understanding of near miss is a little bit more. I say I am of the view that when you do the accident investigation, you will find that the accident could have propagated further, but it was prevented by some other barrier. And in which case, that is also a near miss. I'll give you a typical example. There was an explosion, if I remember, in Bayer Crop in US, which was done by CSB. And some missiles went from that explosion and fell some 10 meters away from MIC storage tank. You know what MIC could be?
Yeah, Bhopal.
If that storage tank would have been there where it fell, then I don't know what would have been the count. This is a near miss, absolutely a near miss. So the point is, when you do the accident investigation, the root cause analysis is one. Second one is what has prevented it further propagating it, and whether that barrier is sufficient enough for a more violent incident, very similar to that in the plant. So the near miss is not only recording as a hazard warning system, but also tells you the criticality of your barriers, how far it is, works as a barrier against damage, and whether that can be penetrated and further major incidents could take place on that.
But at this stage, do you think...
let me complete. For example, when you really, if you go to some of the chemical cluster, everybody pushes the flammable chemical storage to the compound wall because it has to be away from the plant. Similarly, the neighboring plant could push all the toxic release storage to vicinity, So when you do the risk analysis, you will do the risk analysis only for the premises, not the holistically. And holistically, when you do, you may have some incident which has got a domino effect, which could create a major disaster for the community and to the plant.
Fine, sir. One more small question on the near miss. At this stage, where you have met as many chemical industries, this capturing and archiving and analysis of near miss incidents has been adapted to everybody, or are there still some units who may not have brought it in as a protocol? Would there be chemical units to this?
See, you have to divide the chemical industry into various levels of sizes. A small scale industry or a medium scale industry may not really have this kind of a thing. But most of the larger unit, I can't really find out what is the larger unit is. That is definitely have a near miss. But the point is the critical importance of the near miss, whether that has been taken as learning lessons and during the training it has been really, investigated and in the training it has been communicated. And then the risk perception. See, unless the risk perception is better, you won't even recognize the near miss. So it is important to create that risk perception through various sensitized people with various incidences and what can go wrong in the plant itself. And then only the near misses are captured and brought. And I think it is being done in many places. It's not that it is not done. But there are places where it is kept dormant.
Okay. Sir, I would like to ask you this question about giving importance for safety and risk management at the design stage. Why it's important for somebody putting up a new plant to consider this with due importance and due priority to apply this safety and risk management filter when they design a plant. If somebody wants to postpone or defer a particular investment or a particular aspect of safety or risk management for a later, maybe they may think that let the plant stabilize, let us make the project itself viable, then we look at this. Is that a compromise investor is going to do if he wants to bring in safety or risk management aspects to a later date instead of applying it at the design stage itself?
See, look, as far as the petrochemicals and refineries are concerned, they are all more or less a process which have been completely analyzed, and it is a very proven process. What we call is a proven process. But as far as the bulk drug or agrochemicals and perfumery chemicals are, the chemistry is very well known. But the laboratory which is really creating this process should understand the risk factors fully about the chemistry of that also. What we called accelerating rate calorimetry and similar such studies are to be done to know whether this chemistry will become a rogue chemistry at some temperature or some stage. That must be very clearly known. If that is not known and you give it to a designer, the designer only is sizing and providing the adequate utilities, and then if the pressure goes up, relief based on the vapor conditions and things like that. That is of they cannot understand whether the chemistry is a rogue chemistry or not. They will only take all the relevant parameters and design this. So the designing is starting from a process design there, where the technology transfer should be such that all these items on rogue chemistry must be fully understood by everybody. Then that has to be discussed, and then the plant layout and the construction comes into the being. And many times, even in petrochemical plant, recently I have found, because of lack of availability of space, the interplant distances and control room distances are many times a bit of a compromise. Now, but there are also studies like occupied buildings. whether they will get affected by any of the incidents that is being done. But let me tell you for your question, if genetically something is wrong, when you create it, and then trying to undo it is extremely difficult. It is impossible. You can only bring in certain things which can minimize, mitigate, or prevent to some extent something going wrong. So in the genetic defects, which I call it, in the design defect and process design, I think in later stage it is very difficult to really do it.
It could be even expensive, but in terms of viability, difficult to alter or modify. Expense could be another factor beyond the technical possibility.
In my view, it is extremely difficult. But what happens is, as the technology progresses, what you know today, tomorrow you know something better than today. Then you realize that what you have done could have been improved. So these issues will keep coming. But at least with the available understanding of technology, available understanding of the risk, we should really lay out the plant in such a manner that it really serves its purpose.
At this stage, I would request participants, if you have any questions, please put it in chat box. I'll be very happy to raise those questions, Mr. R.R. Balakrishnan, and get an answer right in this session. So I would encourage you to please put your questions in the chat box. Sir, the next point I would like to ask is how important...
Somebody is raising the hand. Would you like to go into that, or later you would like to go?
Maybe I request Mr. Murthy to put his question in the chat box. Thank you. Sir, the next question I would like to ask is the importance of doing something at a pilot plant itself, than before going into the large-scale commercial erection of the plant. Can you explain something about why it is important to bring in a pilot plant stage before the installation of the full-scale model of the plant?
One obvious reason for what I have said. What when you are doing developed a process in a laboratory in gram scale, even when a gas comes out of it, you can always keep your face that side and say as if nothing has happened. And even some effervescence comes, you don't really recognize it as a potential problem. But when you are scaling up into kilogram scale, naturally, whatever is the negative aspect of the process will be thrown up, because you cannot invest in a big plant and then try to rectify those things. It's not possible. And therefore, even when you want to give a vaccine, you have a dry run and a pilot run, all because you can go wrong when you are doing something something later. So similarly, in a pilot plant, you are taking it at a kilogram scale so that anything going wrong can be handled also. But even in the pilot plant, when you are taking a hazardous reaction, we always tell people the layout should be such that some barriers are there. So even if it goes out of hand and there is an explosion occurs and it is contained within the barrier. So these are the issues that will come out in the pilot plant. Some of the waste that is generated in the lab scale may not be of significance, which you may overlook. Whereas in the pilot plant, you know that these waste have got is a problem when it goes with environment or pollution control and things like that. So that is also another issue. So both safety and environmental issues and the yield, because unless the yield is optimized, you can't make profit out of the product. All the three has got to be studied in depth before you scale up. And it is always, a pilot plant is extremely useful in narrowing down your slips in these areas.
Thank you, sir. I can see the questions have started flowing in. First is Mr. Bala Siva Srikanth. His question is...
I have to tell the question is, that remember one thing, nobody knows the answer for all the questions in safety. That's the one thing I can. It is not a preamble to say I am ignorant, but it is a preamble to say this will be the situation for all of us in safety. So it is always, you must feel vulnerable about unsafe situations.
Absolutely, sir. But I think definitely our participants would like to dig into your mind to get answers for these questions with your 4.5 decades experience. The first question is with Mr. Bala Siva Srikanth. His question to you is, can you please give an example, actual example from the recent process safety incidents in which there was a design failure? At least one example, sir.
When you talk about design failure, is he asking about process design failure or engineering design failure?
His question is process design failure.
Yeah, I'll tell you a classic example. I will also, this I have several times told, but I will, again, I will put my, I will share the screen with you and then explain to you. See, you are seeing the three things. One is a glass-lined reactor top, which has flown across nearly half a kilometer and landed in the neighboring site. And this is this. This is this. And then you also have, this is where the vessel was there. And the next one is another still, which has become a sheet. What has happened in this case and that case? In this case, first case, where the entire vessel top blew through this thing, where the decomposition temperature of the residue in which the of a distillation is decomposes very violently, which was not really understood during the process development. What has happened is in a vacuum distillation, there was a failure of vacuum because of the power failure. And when the vacuum fails, if you don't cut the steam, the distillation will stop because it only distills at the vacuum. And the moment the vacuum goes, the boiling point starts raising. So the steam is also still feeding in. So what happened is the temperature of the mass inside the reactor goes up. And if it reaches the decomposition temperature, then it violently decomposes. And then the energy release is so much that it flew up. The bottom portion flew down. So this was a thing that was not realized. And because no process study was done in this direction. And so when this happened, unfortunately, people were not there at that point and no casualties were there. This is I have time and again and shown it to many people. This is a DMSO explosion where a process change was adopted. Instead of methyl iodide, they introduced methyl bromide because that becomes cheaper. This is again a modification in the process modification which went wrong. And what happened was bromide will depress the decomposition temperature of DMSO, which resulted again during a power failure. This resulted in decomposition of the DMSO. Fortunately, what happened was first the relief valves of the still opened up. The people were very sensitive to this. This is what I'm saying, the perception of the people. They cleared the place. They ran away from that place because they know once the DMSO start decomposing, there is no reversal of this. So then the rate at which DMSO decomposing and the gas were generating inside the reactor is far from what can be relieved through the relief valve. And so the pressure went up and the entire still exploded violently, wrecking the whole plant. So this is the typical example. There are umpteen number of such incidents are there. In the construction stage also, we had a thing. After some 20 years, suddenly a pipeline failed in an FCCU. and that pipeline was a small piece of pipeline connecting two pipelines. Then we realized during construction, they had a shortage of pipeline. So the contractor themselves made up a mind to bring another material of construction and weld the pipelines. And so the rate of corrosion of those pipelines was far in excess of what is expected of actual material of construction pipeline, and it failed and created a major incident. When then we took up the pipeline, and then we really did the metallurgical thing, then we found that the pipeline that was installed was not as per the original specification. These things do happen.
So we have a question from Mr. Varun Gavarikar. His question is how to classify causation. He is referring to the Beirut blast, ammonium nitrate blast. How to classify causation in regards to causation analysis for blasts that have sonic boom associated with them, the incident that took place in Beirut.
Well, I have so far, see, when an explosion takes place, we only define explosions on the basis of vapor cloud explosion. Now, what you are talking about, the type of explosion, whether it has got other characteristics like sonic boom and other things. I have no knowledge about that classification of that. But the classification of explosion is based in my understanding is, some of them are molten metal water, phase change, and it creating an explosion, or runaway reaction that creates the kind of an explosion, or a vapor cloud explosion that creates. But if he is looking for something else, I have no knowledge about that, and so I will not be able to do it. As far as ammonium nitrate is concerned, it is one of the nitrate is concerned, is one of the things that keep happening. I think it happened in France, and now it is happening somewhere, and it will keep happening, all the things. So I'm sorry, I'm not able to classify the explosion as he was saying.
That's fine, sir. So Mr. Venugopal Rao from Hyderabad asked a question which I already wanted to ask you. How important is it to consider the cause of loss or a risk event to be either accidental or man-made? Very often, major accidents are caused because of human error. So when you look at cause of loss, out of, let's say, 10, how many would be accidental, purely accidental, without involvement of a human error? How many could be originally caused entirely by human error?
See, every process plant and maintenance of the process plant, everything is done by human beings. Unless there is a human error is there in one of the things, it can never happen. Most of the things cannot happen at all. So if you are talking about somebody opening the wrong valve only as a human error, I am not saying that is a human error. The human factor, which the error I am calling it human factor, runs through from I have given you the example of developing a process, then doing the design, then erection, selection of material, and running and maintenance. Everywhere that is going to be there. So the human factor and human error are bound to be there. So I don't think you can dissociate a plant. Maybe you may say even act of God is not a human error. I would rather say, if you can design a plant to withstand the act of God, and in all probability that plant would stand. So the only thing you can go beyond human error is act of God. But even that, in my opinion, you really consider from the angle of siting the plant, as well as designing the plant to withstand what is expected of the act of God incidences. I think one can really this thing. For example, Bhopal, you see, Bhopal leak, if it were in near to sea, it may be less damaging. It is in the central India, that too in December, so there could be inversions, so the gas could not have dispersed. So that's one of the factors which could have led to the things. So many things like this need to go into it, and they are all based on human factors and human factors are based on the knowledge prevailing at that time. So, and also the knowledge of the person who is implementing that.
Thank you, sir. Question from Mr. Daita Venugopal as to what is the regulatory requirement as to frequency of mock drills for on-site and off-site emergency plans. Is there a regulatory requirement?
Yeah, I think Factories Act or Factories Rules has got something once in a year or something, or once in, I don't remember, but there is a regulatory requirement which is there in Factories Rules. So one needs to really carry out that. And the mock drill, the mock drill when you are talking about, I have had an interesting incident where a fire took place in the first floor of a plant. And the people, I'd been visiting that plant prior to that, so I insisted that you only have the stainless steel, not stainless steel, this thing, ladders, stairs, which is unacceptable because during fire it will become hot. So they all listened to me to a large extent. So they created a RCC based thing. They were able to use it and they were able to go in, but they were not able to go near the fire because the heat radiation was more. Then I asked him, but you have proximity suits. Then they jumped out and said, sir, we forgot there is a proximity suit we had. I said, why? What happened? You are doing mock drill. Sir, mock drill, there is no fire, so we are not wearing the proximity suit. See, this is what happens, you have to really perceive and conceive that is happening there. And how will you perceive and conceive when it is not happening there? See, that is where the real mock drill comes. Otherwise, it will become a mock.
But again, there are incidents where during the mock drill, there were accidents. Particularly,
yes, I know one lady died in Bangalore or something like that. Let's not get into that.
Yeah. Fine, sir. The next question has come from Mr. Raghurama Raju Saripalli. What he wants to know is which RCA technique would you prefer during accident investigations? Are there different techniques, and is there a particular technique?
I am using my common sense and going through collecting all the data, all the DCS data. See, I've been of late few incidences in circulating fluid bed boilers. Ductile explosions are becoming prevalent in those things. You collect all the DCS data and the incidents, the type of profile the process plant was having prior to that, the 3-4 days before, and take the sample metallurgical, do the metallurgical analysis and find out what is the likely release of energy that has taken place. All these things welded together will create a fairly decent root case analysis. I know people like that. There are systems which says you go proceed this, but if you are rationally approach this, I think you can do the root cause analysis very clearly.
Thank you, sir. Next is a question from Mr. Sriramamurthy Duburi from, I think he's from Hyderabad, from DNV GL Hyderabad. His question is there a mechanism to identify near-miss incidents? He believes there's no mechanism. Do you think there's a mechanism to capture, analyze, and archive near-miss incidents?
Well, let me tell you to him that we in Asia Pacific use their software quite extensively and deal with their London counterparts whenever there is some bug in that software, which is being appreciated by DNV also to a large extent. Yes, I agree. The near miss is always recognized by a human being most of the time, either looking at the data which is coming in front of him or looking at the plant which is in front of him. So it is the human being. Ultimately, the human being are the key people in really pointing out what is going wrong, what is likely to go wrong. So the near miss, if you want the near miss to be captured, as you correctly said, there is no procedure that exist as such. The only thing that exists is you are, as a human being, you are people who go around the plant looking for near misses. And to look for a near miss, you need that knowledge. When you look at it, what is wrong? For example, when you go to a plant, I went to a plant which is handling corrosive as well as flammable material. The relief wall, header is made out of HDPE going to a dunk tank. Then I asked the designer as well as the plant people, you have designed the entire relief system for spill fire. If the spill fire takes place, will this pipeline really withstand? They said, yes, it cannot withstand. I have to now change it over to a lined pipeline, and then they did it. The reason why I am saying is, if you are sensitive, if you have the real exposure to various incidences, then looking at it, you will know what is, you can capture realness. As a matter of fact, the explosion which I told you, which I have shown you in the control room where it was damaged, it was a vapor cloud explosion. The vapor cloud explosion, as it swept across the ethylene tank, the ethylene tank magnetic hatch, which has got one at one edge, it is fixed, another is flap will open. So what happened is opened up and fire happened. If the fixed edge is facing towards the plant, the whole explosion wave would have gone across and it would not have opened. To sight easily parallel, if you keep a book, when the fan is going, it will flip. But you change the notebook with the binding coming on the other right side, it will not flip. So it is something that even as simple as that has to be, you will be captured if you are sensitive enough. And only human beings can really capture near misses, in my opinion. I don't know. Maybe I don't know the procedures available. So I'm saying how I capture near misses. So that's it.
Thank you. Thank you so much, sir. We have just another 5 minutes to go. I may extend by another 5 minutes because so many questions are there. But I'll ask next question, sir. This is a very interesting question from Mr. Venkatesan, director from Bharatri. What he says is, sir, I've heard you talk about disasters or sudden manifestation of slow but continuous degradation. Can you explain that, sir?
Yeah, this is what it is. Even a near miss is a continuous and slow degradation. Whereas disaster is the near miss manifesting into a major incident. So, yes, I think he caught it when I made one presentation where I was talking about two people going to 150th floor to look at the beauty of the city, and they get the call from their CEO. One person takes the lift, the other person says he's foolish. I can jump from the 150th floor and I reach faster. So when he jumps from the 150th floor, when he crosses the 50th floor, he says, I'm fine. What is wrong with it? Even at the second floor, he's saying he's fine. But of course, you know what has happened to him. This is exactly, it is asking for disaster. This is one article written by somebody I really...
Pascal Pedossi, sir.
Pascal Pedossi, correct. And Pascal Pedossi, beautiful article, one should read to know how we are indifferent towards things that are slowly deteriorating, because that is more useful with respect to our health also. Equally, I am also bad in that because I underwent a bypass last year. I know being diabetic, it will progress like that. Only thing is, I was sensitive enough to capture. Let me tell you, I honestly captured just before something major happens. But human mind always believes you can postpone things.
Absolutely, sir. I have the same experience. I also underwent a bypass surgery 4 years back, but I never knew I was a heart patient. I went for a cardiac retinopathy examination, and incidentally, somebody asked, have you ever undergone a master health checkup, particularly cardiac evaluation? I said, never done in the past. And then the next 1 week, I came to know I underwent echo and ECG and treadmill test, and then also a angiogram. And I ended up with 3 blocks. It would have never been found out otherwise. I didn't have any symptom, nothing, but a different test led me into this. It would have been near miss for human beings. So I have this question from Mr. Bertie Ezra, who's a very senior insurance professional, formerly New India, and he's been a broker from Philippines. He's just come back from Philippines to settle down, and he has joined Bharatri in Kolkata. Mr. Bertie Ezra wants to know about the standards for earthquake design of buildings. What should be the seismic tolerance of buildings? What are the standards in India?
There are Indian standards are there. I think 1893 or something like that. ISBAS. I don't remember.
That would differ from civil construction and plant design, sir. Chemical plant design.
Yeah, it will always. These two things will be different because the pipeline swaying and things like that. There is a differences there. I'm not a specialist in that, but that for as well as the building is concerned, it is there. And for this thing also, there are standards which can be.
So one question I wanted to ask is very important for me in terms of how we look at how organizations evolve and mature. What is the weightage to be given by a plant owner or entrepreneur for risk management training? How important is training when it comes to giving inputs to plant personnel as to how they should be sensitive, even capturing near-miss incidents or predicting a possible trouble in terms of safety? Does training help, and how much does it help?
See, the most important thing is, if your production is important, is equally important to understand the risks and really develop risk perception. And if he develops a risk perception, there is no need. He will see that everyone in the plant will be really have the correct risk perceptions. So it is the owner who has to develop the risk perception. Once the owner has developed the risk perception, I know some owners who are very, very particular. If tomorrow, if they have to go from Bombay to Pune in the car, they will see to that the driver comes the previous day, sleeps in the guest house so that he doesn't drink or anything and take the vehicle. There are such meticulous people are there who are, they conceive that incidents can. So there are number of people. So the risk perception of the top man is the only way that will flow down to all the people. And if he starts believing, if he starts talking, if he really appreciate that. See, the whole problem is, if I go with a problem with the top man, he will bark at you. All the time he brings the problem to me. So one control system engineer asked, whenever there is a problem in the field about pressure or this thing, control system says there is something wrong. You acknowledge it and try to correct it. But when a human being comes and tells the people there is something going wrong, please try to correct it, he'll say he is the only complaint master, he has no this thing. So that attitude will change if the risk perception of the top man is correct. And most of the accidents occur during January, February, March, because they postponed the problem to be taken in April. That's the issue.
Yeah. Talking of risk perception, so there's a question from Mr. Ali Pasha Saudagar. How risk assessment is to be done for an aging plant? You mentioned about plants installed in 1950, Fitzborough 1974. What about aging plants and how the approach should be taken for risk assessment?
I think there are a number of articles as well as number of, HSE, UK HSE is also talking about how to go around doing that. So I'm not really gone into it. All that I know is even in aging plant, there will be an indication of something is going wrong. But invariably, I come across this in the tank farms, because most of the tank farms are not being tested. Very recently, I had some corrosion failures in some of the tanks also. So the point is, there should be a frequency of non-destructive testing as well as vibration monitoring of the rotary equipment and things like that. And you by case study, you also know, and by history, that certain type of equipment and certain type of industry, they undergo a problem. And so you, for example, in the urea plant, the urea reactor gets into corrosion and it fails after certain years. In 1994, urea reactor will fail around after 20 years or something like that. You know it. So you have to have a schedule of replacing those things. And I have enough of such damages, ammonia leaking, ammonium carbamate leaking through some of the failed urea reactors, which are operating at 180 bar. So this is the monitoring is required. You know the previous experiences from others, and finally replacement. That's how we can do, or completely mothball the thing.
Correct. So a few years back, similar discussion took place about cooling tower failures one by one in fertilizer plants. Possibly it has got a linkage to their aging. Possibly so.
No. Because I was being involved very this thing, and I have attended some vigorous, cross examination.
Got nothing to do with aging, sir?
No, I'll tell you, it did happen because cooling tower has got a long life. But what happened was, it depends on the wood. What Himalayan wood was used in cooling tower initially. Then there was a court ruling that you can't use the wood from the Himalayas. Then they shifted to African. This African thing has greater, it started deteriorating. But the most important thing, the design had a common header for all the cells. There were like 4 or 5 cells. And so the entire load of the header was coming on this. So then what they decided, each cell will have independent delivery system, and there won't be any header on top of it. We had some 10 to 12 cooling tower collapses.
Yeah, in a span of, I think, 3-4 years.
Yes.
Okay. So next question is, how do we cross discussion like this, especially in 2021, without talking of technology? There are two things I wanted to ask you, sir. In your practice of advising corporates on safety and risk management, what kind of technology you are using? The question actually has come from Mr. Sanjay Bharadwaj. This question to you, sir, how artificial intelligence or new technologies play a role in risk management as compared to human inspection?
Well, I wouldn't know exact, because I have not used artificial intelligence. I strongly believe a good human being can even speak to the machine, and an artificial intelligence may not. You may wonder how. I have experienced, when I walk through the plant, the equipments will tell me their health is not good. How does it happen? Because you are so sensitive for every sound and every movement of the equipment. Whether that kind of sensitivity ultimately can be done in artificial intelligence, yes, it may be possible, but at that, I don't know whether that is possible now. So, well, people are using artificial intelligence, and they may think they're successful. But one thing I'll tell you, there is always a question mark. In India, in spite of we criticize ourselves of being not safe and things like that, Indian plants many a times avert many of the major disasters. As against this.
Is it by karma or by design, sir?
No, that is because we have a number of human beings going across the plant, all the time looking into the plant, have a feel for the plant, being affectionate towards the plant, and feel part of the plant, which I think in other countries it becomes very difficult. You may wonder, it looks irrational. No, it is so. The guy will tell you, this is going to fail. And that is how I believe that whether this can be again put into artificial intelligence, I don't know. Like artificial intelligence, can it be a better wife to you than your wife? If somebody asks me the question, I will not be
But
in a position.
I know how many near miss incidents I can capture on that particular topic. But we already breached our time by another 8 minutes. The last 2 minutes we have. My final question to you, sir. You meet as many stakeholders and business owners. There is somebody who followed your advice, and then they found the benefit of that when an event occurred because they followed your advice on safety or risk management. They benefited. But there's another person who listened to you, who heard you, but did not follow your advice in terms of safety or risk management, and he had to face financial outgo or a difficulty. Can you cite examples for both this? Who followed you and gained, and who did not follow you and then had to face a difficulty? Actual,
Well, I may take 5 minutes for this. Is it okay
please.
for you?
That's the last question, sir. Please.
See, in one other plant, I found that the shift in charge was sitting in a place where he has to cross the one reactor to get out of the plant in the first floor. So I told him that is unacceptable, because if there is any release there, then he cannot cross and he will get captured totally and he will die. But that was the plant people are not accepting, but the owner was sitting. I was asking to give an escape behind him so that he can quickly get out of the plant by going, running away from the thing. The plant was reluctant. The plant said, this is a reactor where we don't use anything hazardous. We are only using this for material which is only water-based material, and no toxic chemicals are used. So why are you insisting on that? I said, I am uncomfortable. I need to have this done. The owner always believes in me for reasons unknown, because I was with him for 35 years. So he told them how much does it cost. Those days is 50,000 rupees. He said, do it tomorrow. And they put that. And after a few days, there was hydrogen sulfide release, and people rushed to that plant. They found two of the shift in charge, shift and his deputy, was lying in open air in the new escape staircase, but still alive, and they saved it. The point is, one of the reactor was not properly operating, some breakdown occurred. So they transferred all the material into this empty reactor, which was not fully engineered and this thing. So as the reaction went, there was a leak. So this is a thing, I still believe that God has been kind enough to route it through me, and kind enough for the owner to listen to it, and the two lives have been saved. In another incident, I was going through the R&D lab, and the R&D research chemist said, sir, some white fumes are coming. What do I do? I said, you have to do accelerated reaction calorimetry to know what is the violence with which this compound will decompose. Then after 4 months, I went there. He was said, I said, did you do ARC? Sir, management doesn't want to do any ARC. They want to take it in the plant.
What is ARC, sir?
Accelerated rate calorimetry, which will tell you what is the decomposition temperature and rate at which it is going. Then this man, I said, where are you taking this reaction? He took me to the plant, and it was a reactor with the working floor on that. And there is a staircase near the reactor and another staircase away from the reactor. I told them, the moment you feel there is a white fumes coming from the vent, because those days they have not put it in any scrubbing this thing. So if you see that, the next thing you do it, don't take the nearby stairs, because still you will be near the reactor. Run away and take the stairs which is far away. This is a lesson I learned, in the beginning I told you, running away is the... He said, fine. Then there was a major explosion. Then the MD called me and said, Bala, I said, what? There was a major explosion in the plant. Can you come tomorrow? Catch the flight and come. Anyway, this is also Hyderabad one. So I said, fine. I went there and then I asked him, is there a casualty? Because I was keen. He said, that guy is smart. He ran away. So I came and he met me. And the moment he met me, he hugged me and touched my feet and said, what happened? Sir, the moment that white fume came, I saw your face saying, take that ladder away from the plant. So I ran and literally I got saved. Why I am saying is, the risk perception is not to avoid only losses or the major incidences. The risk perception totally is required how to handle a situation. That is very important, because if you don't know how to handle a situation, you can be consumed by the situation.
Fine, sir. It's been a fascinating 1 hour plus 10 minutes discussing with you. So many questions came from. There are a few more questions, but I think for the benefit
You
of
must remember, I am 74 now. So, the energy levels are not as good as they used to be.
I'm sure all your clients benefited in the past, and they will benefit as much as you engage with them. So it's been a fascinating 1 hour discussing with you, sir. I must thank you for providing a response to as many questions. Jitu Bhai from US is saying hello. He has seen the whole session, and our friends from Sri Lanka, Kenya, Tanzania, Uganda, and so many other countries. We'll be uploading the session shortly on Bharat's YouTube channel, and so that people can review it later. We would again come back for another session. Possibly Mr. R.R. Balakrishnan and myself will sit again to discuss cyber risk for manufacturing industry. That could be a topic we'll take up in the short future, because cyber risk is bothering everybody. So I would like to pick the brain of Mr. R.R.B. from his viewpoint. If manufacturing and chemical industries particularly are using technology, how cyber risk can operate. We'll come back with another session. It's been a pleasure having all the participants around, our customers and prospects, and invited guests and Bharatri teams all over India. We thank everybody, and we wish you a happy new year, and all the best for your business. Thank you very much. Thank you, Mr.
Thank you
Balak.
for all the participants, and any shortcomings, please forgive.
If there are any questions which have not been answered, we will respond to them with Mr. Arabi's response offline. So we promise to get back to you if those questions have not been answered. Thank you very much. Have a nice evening. Thank you so much.
Thank you.